All right, let's just jump right in. Today, we are cracking the code on Apache Spark. If you're in the world of big data, or heck, if you're just trying to nail that next tech interview, you know this is a huge deal. We're going to get straight to the fundamentals.
Okay, so let's start with a classic scenario. Picture this, you've got a massive 1 terabyte data set. Your laptop is practically smoking just thinking about it. So what do? How do you possibly process all of that on just one machine? The short answer, you kinda can't. And that is the exact problem Spark was created to solve.
I mean, sure, you could try to beef up your one machine, right? That's called vertical scaling. You add more RAM, a beefier processor, but it's like trying to build a taller and taller skyscraper. Eventually, you just hit a limit. It gets crazy expensive or just physically impossible. The real game changer is what we call horizontal scaling, linking a whole bunch of regular computers together to work as a team.
To really get this, let's ditch the complicated charts for a second. The core idea is actually super simple. I want you to think back, maybe to your old school computer lab. Seriously, this one simple idea is the key to unlocking how Spark works. Let's say you've got a lab with 30 computers, another one with 30, and a third with 30 more. Now, what if you could magically link all 90 of them together so they act like one single massive supercomputer? That huge 1 terabyte file? We just chop it up into 90 little pieces, and each computer works on its tiny piece at the exact same time. In Sparkland, we call these individual computers nodes. And that whole group working together, that's your Spark cluster. Okay, so you've got the computer lab in your head. Perfect. Now let's map that simple idea onto how Spark actually works under the hood. It might sound intimidating, but I promise if you just keep thinking about that lab, it'll all click into place.
So pretty much every Spark job follows the same basic flow. First, you send your code off to something called the cluster manager. Then, the manager points to one computer and says, you're the driver. That driver then looks at your code and basically creates the whole game plan. It breaks the job down into little bite-sized tasks. And finally, it dishes out those tasks to all the other computers, the worker nodes, and they all get to work at the same time.
All right, let's look at those pieces. First up, the cluster manager. This is your lab administrator. They aren't doing any of the actual homework, but they know which computers are free, which ones are busy. Their job is just to manage the whole thing and get the process started.
Okay, next is the driver program. This is the absolute brain of the whole operation. And this is a super important point. The driver does not process your data. It doesn't do any of the heavy lifting. Think of it as the project manager. It just looks at the code, figures out all the steps, and then tells everyone else what to do.
And finally, that brings us to the worker nodes. If the driver's the brain, these are the muscles. These are the guys who actually roll up their sleeves and do the work. They get their instructions from the driver and use these little things called executors to chew through their piece of the data. They don't ask questions, they just execute the plan.
Okay, wait a second. Cluster managers, drivers, worker nodes, this sounds awesome, but also like a massive headache to set up and manage yourself, right? So, if Spark is this powerful engine, how in the world do you use it without being a systems expert? Well, that's where Databricks enters the picture.
You can think of Databricks as this beautiful, user-friendly dashboard for Spark. It's basically a platform built on top of Spark that handles all that nasty, complex stuff for you. It spins up the clusters, it configures them, it maintains them, so you can just focus on writing your code. And that's really the whole idea. With a platform like Databricks, that entire nightmare of managing a cluster just goes away. It's all handled for you. It lets your team tap into the raw power of Spark without needing a PhD in infrastructure.
All right, so we get the tech, we have the components. But let's switch gears a bit. How do people in the real world, professionals, actually use Spark and Databricks to build data pipelines that you can actually trust in production?
Well, they follow a really structured process, usually called CI/CD. It's all about moving code through different stages. It all starts in a development environment. This is like a sandbox where data scientists can play around and experiment without breaking anything. Once their code looks good, it gets promoted to staging. This is where it gets put through the ringer with all sorts of tests. And only after it passes everything does it get the green light to go to production, where it actually runs on the real, live data.
And you got to understand, this is totally a team sport.
You've got your data engineers, who are the architects building the data highways and making sure the data is clean. Then you have the data scientists, who are building the smarts, the actual model training logic. And finally, you have MLOps engineers, who are like the air traffic controllers, making sure the whole deployment process runs smoothly and keeping an eye on everything once it's live.
This whole professional setup is built on a few really important principles. First, you version control everything in something like Git. And I mean everything. The code, the infrastructure, the job setups, all of it. Second, you automate your testing. No manual checks. And third, and this is critical, you keep your environments totally separate. What happens in dev stays in dev. It should never, ever be able to mess with your production system.
And here is a golden nugget for all you pros out there. The absolute best practice isn't to just train a model in your dev environment and then copy that file over to production. No. What you do is you promote the code that trains the model. Why? Because you want that model to be retrained on the freshest, most relevant production-grade data. It's all about making sure your model is reliable and up to date.
So there you have it. We've talked about the incredible engine that is Spark and the professional assembly line that makes it work in the real world. But a Formula One engine is totally useless if you fill it with dirty, low-quality gas, right? And that leads us to the final critical question. The engine is powerful, but how do you guarantee that the data you're feeding it is reliable and trustworthy to begin with? Well, that's a story for another time.